Hello students. So in today's concept of capacitor, I'm here with a problem. You see the question is what? There is a capacitor of each plate in the form of a square of side A. So the plate area becomes small a into small. Separation between the plates is what? D. Separation between the plates is D. And at the lower side there is water with dielectric constant K and density rho. And the two plates are connected with a potential difference of V volts. Right? Potential differences or V volts across the plates. Now the question is that in equilibrium, water will rise up to what level? In equilibrium, water will rise up to what level? There's a question. Right? So you see कि इक्विलिब्रियम में वाटर कितना राइज करेगा. सबसे पहले इसके लिए फंडामेंटल कॉन्सेप्ट क्या है? You'll see the fundamental concept is this. Suppose you have a capacitor of whose plates are square. Each plate is in a square A into A, connected with the voltage of V volts, and separation is T. Suppose there is a dielectric slab of dielectric constant K inside the capacitor, and its X length is inside the capacitor. So if X length is inside the capacitor, the capacity of this system C will be C1 plus C2. There are two capacitors here. One capacitor is what? This one without dielectric. So C1 becomes A into A minus X epsilon naught upon D. I hope you understood. How you can understand this? ये इस तरीके से स्टूडेंट्स इसकी यानी लेंथ है a minus x और जो लेंथ आपको दिखाई नहीं दे रही अंदर की ओर है, that is what a. So area into epsilon naught upon d, and the capacity of this part will be a into x is the area into epsilon naught into k upon d. This is the capacity c. This is the capacity c. So now see the energy U will be equal to half CV square. Energy will be what? Half CV square. You see energy will be what? Half CV square. So energy U becomes equal to, U becomes half, C is A epsilon naught upon D will be common in the C, and this will be A minus X plus KX into what? B square. This is the energy. Now because the energy is a function of X, that means force F will be minus of d by dx. Force F will be what? Minus of d by dx. So that will be equal to minus of half A epsilon naught upon d into B square, and its differentiation will be K minus 1. So you see this, because K is greater than 1, so this term will be positive, so overall the force will be negative, and negative force means what, students? It will be, this will be what? Attractive force. So that means this much of attractive force will be acting on the dielectric. Attractive, that means towards the capacitor. कैपेसिटर के अंदर की ओर फोर्स लग रहा होगा अट्रैक्टिव, और फोर्स का मैग्नीट्यूड x के इंडिपेंडेंट है. फोर्स का मैग्नीट्यूड क्या होगा? x के इंडिपेंडेंट है. Now look at this question. This was the concept. Half A epsilon naught into B square upon D into K minus 1 will be the, this will be the attractive force inside the capacitor. Now see. Now look at this. In this case, what we have is attractive force is equal to how much? It will be half A epsilon naught into K upon D into K minus 1. The moment water comes into contact of the capacitor, the moment water comes into the contact of the capacitor, attractive force will start acting on it, and water will keep rising. Water ऊपर की ओर जाएगा. अब the water ऊपर की ओर इस attractive force से जाएगा, तो water का weight mg नीचे लगेगा. बट स्टार्टिंग में mg की वैल्यू कम है क्योंकि उसका वाटर कॉलम जो ऊपर गया है अंदर वो कम गया है. तो वाटर कॉलम कम है, दैट मींस नीचे की ओर का वेट कम है, और ये अट्रैक्टिव फोर्स एक कांस्टेंट फोर्स है, ये स्टार्टिंग से ही इतना है. सो दैट मींस की वाटर विल बी एक्सेलरेटिंग, और द वाटर उस पोजीशन पे पहुंचेगा जहां पे वाटर कॉलम का वेट, जैसे मान ली वाटर h हाइट तक राइज कर गया. अगर वाटर h हाइट तक राइज कर गया तो वाटर का वॉल्यूम हो गया आपका a इंटू h इंटू डी. आप समझ गए, जो पीछे वाली लेंथ है a, वाली लेंथ d, और हाइट h, so volume will be what? AHD into rho into g. Is that clear? ये देखो तो होगी AH into D into rho into g. ये इक्विलिब्रियम में है. इक्विलिब्रियम में क्या होगा? नेट फोर्स विल बी जीरो. इक्विलिब्रियम में नेट फोर्स विल बी जीरो. दैट इज नीचे की ओर का फोर्स ऊपर की ओर के फोर्स के इक्वल होगा. बट ये जब वाटर वहां पहुंचेगा तो वाटर वहां पे रेस्ट पे आ गया. वाटर वहां पे रेस्ट पे नहीं आया क्योंकि पहले ऊपर का फोर्स ज्यादा था, mg वाटर का वेट वाला फोर्स कम था. तो वाटर जब इक्विलिब्रियम पोजीशन तक पहुंचेगा, बिकॉज इट वाज एक्सेलरेटिंग, ये कुछ वेलोसिटी गेन करेगा और ऊपर जाएगा. फिर वेट mg ज्यादा हो जाएगा इस वाले फोर्स से, वाटर फिर नीचे आएगा, तो थोड़ी देर वाटर ऑसिलेट करेगा. इवेंचुअली जो ऑसिलेशन वाली एनर्जी है वो फ्रिक्शनल फोर्सेस के अगेंस्ट, विस्कस फोर्सेस के अगेंस्ट, दैट विल बी लॉस्ट. एंड in equilibrium, you see equilibrium means what? Net force should be zero. So in equilibrium, the downward force weight of the water column will be equal to what? Attractive force. So from here you get the value of what? H. So H की value आ गई. A से 1 A will be cancelled, and this becomes half epsilon naught into this what B square था ये. I'm sorry यहाँ पे मैं K लिख दिया था. This what? It is V square. So this will be half epsilon naught into k minus 1 into b square divided by d, or ये density rho is what? It is the density rho. So there's a density rho ah. अच्छा ठीक है, it was d into rho into z. So this will be h is equal to half epsilon naught into k minus 1 into b square upon d into d square into rho into z. This is a height in equilibrium that the water column we gain. So students, that's all for today. This concept, I think you knew very well that how to calculate the attractive force. Here you see, because it was to be calculated in equilibrium, so in equilibrium, what extra you had to do was that the weight of the water column was to be balanced by what? Weight of the water column was to be balanced by the attractive force. So I hope you understood. So all the best students, keep doing the good practice of solving the questions, and that is the only way to improve upon the concepts. All right, students.